Okay, so let's get us started on this session at Global Azure. So welcome from my side. First of all, I'd like to thank the organizers for this great conference. Thank them for having me, allowing me to show my content here, and also to my employer that you can see here. Great company. If you're at some point of time looking for a new job, I urge you to take a look at our open positions. It's really a great company, and I would love to take any applications that you might have. So what are we going to do? Let's hit start on that session. We're going to see how we can use Traefik as a reverse proxy for Windows container-based environments. Yeah, actually the agenda is wrong on top. Sorry for that one. That was the previous session that I did. So what we're going to do today is we're going to take a look at the architecture of Traefik overall. We can take a look at more details of the main components of configuring Traefik, how it works, and how you can manage your containers, the networking in your containers with it. So first of all, to introduce myself, my name is Tobias Fenster. I'm the CTO for the Cosmo Consult Group. I'm also a dual Microsoft MVP, both for business applications and for Azure, and I'm a Microsoft Regional Director as well. That doesn't mean that I work for Microsoft, but instead it's kind of a similar community program to the Microsoft MVPs. Not so technical, but yeah, still another community program. I'm also an ambassador for Traefik and for Portainer. And if you want to get in touch with me, if you like what you're seeing, then feel free to follow along on Twitter, as well as on my blog that you can see here, or also get in touch through Twitter or through LinkedIn. I've also added my handle here as well. I'm always happy to get in touch and discuss anything that you might have around containers, around Traefik, Portainer, Windows containers, and Azure in general. So what I'm assuming for the session today is that you have basic knowledge how containers work and how networking with containers work. So this won't be an introduction, will not be an introductory session. Instead, I assume that we have some basic knowledge. I'll dig into details on Portainer, but I won't show you all the basics for containers. So if you have no clue at all about how containers and networking container works, then this might be a bit of a steep learning curve. But if you already have an idea and want to get started on Traefik and how to configure Traefik, then this is the right session. So first of all, what I want to show you is the overview of how Traefik works. So we'll take a look at Traefik in general. Traefik is an edge router. What that means is that it sits on the edge of your infrastructure, and the edge of your environment. So you have your own services running, as you can see here, service 1, 2, 3. Those are happening on your infrastructure. And then you have Traefik that is sitting on the edge between your infrastructure and everything that is happening outside of your infrastructure. And if you have incoming requests, like you can see here, then Traefik is taking them and knows how to route them into the right services on your side. So basically, Traefik helps with making those connections between the outside and your infrastructure. How does that work? As the most easy example and the getting started way to understand how you can make those connections, you can see service 1 over here. That one says that it wants to handle /first. So if a request comes in with your domain name and /first, then it will make that connection. If you have another one that handles /second and a request comes in with /second, it will make the connection. I think you can already guess we have the third service, and that is listening to /third. It's also interesting to understand that this can happen automatically. So the service can define that it wants to handle those requests, and Traefik takes a look at the services as they are coming up and understands that it needs to do the routing. So the most part of the configuration for Traefik actually is done using that automatic discovery. You only need to let it know where it needs to listen or where it needs to check, and then it will take a look at the services that are coming up, pick up the configuration from those services, and make sure that the requests are handled in the right way and are routed through to the specific environments, to the specific services that you have running. So that also will be my first demo. we will first of all take a look at automatic service discovery and how that works. And for that, we'll switch over here. So we have Portainer as a management environment, and I'll show you that we already have Traefik running up here, as well as Portainer, because we're using that. And what I want to do now is to show you how the automatic service discovery works. For that, I'll add a stack here. And that one takes the Docker Compose file, and I just copy that one in here. So put it in and give it a name. Let's say sysinfo for that one. And it already has a couple of labels. It has the definition of the service. That one is created by me. It's enabled for Traefik, so Traefik knows that it needs to listen for that one. It lets it know that it wants to be connected on HTTP port 80, and it wants to take any request on /sysinfo. And we have a certificate resolver for Let's Encrypt. I'll show you in the end how that works and how we can do that. We will deploy the stack. So Traefik didn't know about that one before. Now we're only creating that container with that configuration, and Traefik automatically picks up that we have a new service and we have a new rule that is connected to that service. So if I just say /sysinfo here, because we have defined that one as prefix, then we immediately get access to that environment. You can also get more environment variable information over here, but that is just the way that I've defined that particular service. So you've seen that it's very easy, and it automatically picks up the new services. Sorry. So what I would want to do here again is that I add another one, sysinfo 5. That is version 5 of that service. So we have another definition here. It is also enabled for Traefik. It listens on HTTP 80 as well, and it has a prefix of sysinfo 5. So if we now update that particular stack, click here, then it will create that container. Traefik will again automatically discover that service, discover the configuration for that service. Now, if I reload, I still have version 4 on my sysinfo 4. And if I connect to sysinfo 5, then you can see that I now have version 5 over here. So again, nothing that we need to put into a configuration file or anything like that Traefik would need to reload, but instead it automatically picks up the configuration of the service. It takes a look at the containers that are created and automatically understands that it can use that one to connect here. Okay, so let's go back to the presentation. That was the first demo. What I want to now show you is how configuration works. So how can we define more? We've already seen a bit of that one, but to give you an overview of the total architecture, we have on the very left from your view here, we have the entry points. So it lets Traefik know what it's listening to, the ports, the protocols, and so on. Then we have the routers in the middle, same as we've just seen here, that has rules. So the host that it needs to listen to, the path, it can look at headers and make the decision where it needs to route the requests and so on. We also have middlewares. Those are used to change the requests and the responses, and we will see in a second how that works. And then on the other side, as I said in the beginning as well, those are the services that are running on your infrastructure, for example, on the same Docker host, but it also could be somewhere else. And it makes a request to that server with, in our example, a particular port and a particular protocol, but it also could do load balancing and things like that. And that way it will route the request to that particular instance. So the configuration is split up in two parts. We've already looked quite a lot at the dynamic part on the right over here, but we also have a static part that we haven't seen yet, and that's on the left here. That defines the entry points, it defines providers, so where do the services come from, and it has additional information and connection configuration. So if we take a closer look at that static configuration, that is exactly the way how I have started Traefik in my environment. And if you create a VM using my quick start template, you can take a look at my first session on Global Azure if you want to understand how that works. It's actually very easy. Then you will end up with the same configuration. But let's take that one step by step. The first part is that we tell Traefik in that case that it needs to look at Docker containers that are coming up. So we're enabling the Docker provider. We are also letting it know that it shouldn't expose the services by default, but instead, as we've seen, we need to put a label exposed, Traefik enabled equals true, so that Traefik knows that it indeed should expose that container to the world using the reverse proxy functionality. If some other container is started without that label, it's not automatically visible to the outside, which is the basic security feature. And we need to let it know where the Docker engine is running. That's just the default endpoint for the Docker engine. That way, it knows where to listen for new containers that are coming up. It also has a secure endpoint. So it's listening on port 443, as you can see here. Everything that is coming in as a request on 443 will be handled by Traefik, and Traefik then will take a look at the configurations, at the routers, at the middlewares to make a decision where and how to route that traffic. I've also said that it automatically can fetch Let's Encrypt certificates, and the basic information that we need for that are here. The first line defines how Let's Encrypt finds out if we're indeed allowed to make that connection, so that we can't get a certificate for some host or for some domain that we don't actually own. So that is the TLS challenge here. Then Let's Encrypt has a feature that sends you reminders if a certificate expires, and this is the email address that I want to use for that one. And we also can let it know where it should store the certificate key. The last thing that we can see here, or the last two parts, are that the servers are allowed to connect to insecure backends. That is important, for example, if you have an HTTPS configuration in your container, but that one is using self-signed certificates, that would usually fail in Traefik because it tries to validate those certificates. But if it's internally for you and you're fine with self-signed certificates, especially for test and demo cases probably, or development, then you need to set that particular configuration. And the last thing that I'm defining here is that the API and the dashboard is true. That means that Traefik exposes a dashboard that we can use to take a look at the configuration. Again, this is something that you probably don't want to do in a production environment, but to understand better how Traefik works and in a dev and test environment, that should be fine. Then we have the dynamic configuration. And again, this is what we've already seen. We enable that Traefik takes care of the requests that are coming in here. It lets it know that the container is listening on port 80 and using HTTP to connect to the container. So as a reminder, when the traffic comes in from the outside, we have HTTPS traffic handled through the Let's Encrypt certificate. And then Traefik knows that it now needs to make a connection to the actual service in the backend using HTTP. So it's removing the HTTPS in here. Depending on your use case, that might be something that is valid, or it might be something that would be classified as a security issue. So this really depends on what your requirements are in here. But it shows you that it is possible to have traffic that is coming from the outside through HTTPS and still forward it internally using HTTP. Then we have the path prefix as a rule. That one says sysinfo4, as we've seen before. So it lets Traefik know that whenever a request comes in from the outside using /sysinfo4, it needs to forward to this particular service. And it also has the certificate resolver that we've seen before. Just to switch back, you can see here the certificate resolver is called myResolver. Sorry, now it should be highlighted. Yeah. So we have the myResolver certificate resolver, and if I go back over here, you can see that we are referencing that particular resolver in the last line. Some more detail on how the Let's Encrypt support works. Again, we've seen the configuration already here, but a bit more detail. How does it know which domain it needs to connect to? Because we didn't set that up anywhere. It is looking at the host rules that we have here. So you can see we have a rule that says that the host is docker minus and then that random string. And the Traefik setup works that way that it automatically takes the information that it has in that particular host rule and uses it to define which domain it is requesting from Let's Encrypt. So that one works automatically as well. We could also have an explicit definition. So we could do the TLS domain definition that you can see here. It could also have multiple domains. So you could also set up something that is not explicitly mentioned in a root. It will also automatically renew if the certification has less than 30 days until expiry. So that is also very handy because the Let's Encrypt certificates are only valid for 90 days, if I remember correctly. And as soon as it gets to below 30 days of expiry, then Traefik will automatically renew that certificate. And you will get an expiry notice to the given email, but that is basically a feature that is created by Let's Encrypt. Okay, so that's the basic information about the configuration and about how Let's Encrypt works. Now let's also take a look at how routing works, how the routers work in Traefik. So what you can see here is that we might have multiple entry points. We only had one in our demo, but we could have multiple one of those. And then we have the routers that are connected to those entry points. So as an example, we have a rule here for a specific host in router 1, and that one knows that if a request is coming in for that particular host, it needs to forward to that particular service in the backend. And we have the second rule that has a host and a path, and it also has a middleware to authenticate, for example, and that one forwards to the dashboard rule. So that is basically how Traefik is looking at those requests. Where are they coming in, the right entry points? What are the rules that define which router should be used? And then because of that, the router knows what the backend is that it needs to connect to. Let's take a look in more detail in how that actually works and switch over to my demo environment again. So let's take a look over here. For example, you can see here that one doesn't have the little icon that you usually see on websites. And if you take a look into the debug tools and refresh here, then we can see that it actually doesn't have the right configuration. Oh, wait a second, did I switch to the wrong one? 1 second, I'll need to take a look here. Oh no. That might be the wrong demo. As you can see, I have. No, sorry, it's the right one. So yeah, we don't have the favorite icon over here. That one didn't work because we don't have a route that is defined for slash. It's looking for slash favicon.ico, and that one is not defined by the routers that we have. So that is the reason why the request fails. What we can do here is that we can add an additional routing rule. So if we go back in here, go back into the editor, then you can see that we only have rules for those prefixes, sysinfo4 and sysinfo5. But what we can do is we can add an additional prefix here. So if something comes in to slash, then we want to redirect it and add an additional prefix. So when something comes into slash, then we want to redirect it to slash sysinfo as well, and we connect that particular middleware. So we have a router rule that now listens to slash, and we've connected it to a middleware. And I'll explain in a second a bit more how that works. But now let's deploy that one. It is deployed. It has a new rule. Traefik automatically picks up that new configuration. And if we now do a reload and pay close attention to our debug tooling, where we can now see the requests, you will see that we now have a favorite icon over here. You can see it over here as well. It has indeed been loaded. And the reason for that is that we now have created an additional rule, an additional routing rule that listens to slash as well. That one, of course, is important because now we can have the direct connection to that one as well. Okay, so much about routing. What I now would like to tackle, yeah, here we are, is how that actually works. So who gets which request? We have seen the host-based routing. We have already seen the path prefix-based routing, but I want to show you the additional options that you have. You can take a look at headers. So that would be the first one. If you have a particular header and want to make a decision on where to route your requests based on that one, you can use that. It can either be a direct key value combination, or it can also be a regular expression, as you can see here, using the headers record. And then we have the same for the host. It can be a defined name for a host, or it can be a regular expression, including things like subdomains. We can route based on the methods. So a GET request could be routed to a different service than a POST request. For example, if you want to have additional caching for GET requests, then it could make sense to have an additional service there as well. We can have a look at the path. That would mean that it's only listening to exact matches of the path, including regular expressions as well. Or we can have a prefix like we've used before, which means that everything that is happening after that particular part of the path will also be redirected to your service as well. And last but not least, we can also take a look at the query. So if we have additional query rules, then we can do that as well. We can combine those router rules, so we can do AND or connections. We can use parentheses to do the or brackets to do the combination and the ordering of those. The default is that they are routed in descending order, with the longest having the highest priority, unless it is overruled by an explicit priority. And to give you an example why that makes sense, take a look at that one. We have a rule that says that in rule 1, if it's coming in and that particular host and has a path of sysinfo, it should be handled according to rule 1. Then we have rule 2 that takes a look at the host expression and the query. And then we have rule 3, and that has a specific host name. So if we now assume that a request comes in, as you can see on the very last line, then the first one will fail because it doesn't have sysinfo 5. Instead, it has sysinfo 4. The second rule will apply because it now has the right regex for the host, although it doesn't have the right query, but because it's an OR matching, it will still match because the host is the right one. And the last one will also match, but it won't get the request because the second one is the longest. So the second one is the one that will actually get the request in here. I've highlighted it here, and that is because it is longer than the last rule. Maybe your intuition would have been that it uses the last one because it seems more specific than the wildcard in the second one, but it really just takes length into account. And if you want to override that, you would have to add an explicit priority if you want to match rule 3 in that particular case. So now let's take a look at middlewares. I've already used the middleware before to add that prefix, but to show you what the idea is. A middleware is used if you take a request and route it somewhere and want to make a change to either the request or the response. Then you can have a change of actually multiple middlewares if you want to. So you're not limited to only one, you can have multiple of those, and you also can define your own plugins, which could have own middlewares as well. And then in the end, of course, it is routed to the right service. Let's do a quick demo how we could use middlewares for API versioning and for authentication. I'll switch over to the demo here. So what I want to do now is I want to use a different image. For that, I will remove our sysinfo stack, get rid of that one, and use another one which provides not a GUI interface, but instead an API. So we will have to use, so we don't have the nice graphical interface, but it's easier to show the different configurations here. For that, I will put in a stack again. Let's copy that over and paste it into that one here. This is my container sys API image that I'm using. And you can see here, it's again listening in port 80. I'm using HTTP, and we're using the sys API path prefix over here. And we have a middleware that is stripping the prefix of sys API. So if a request comes in on Sys API, it knows to route that one to that service, but it's also removing the Sys API part, so the container can get the request en route. Let's see if we deploy that one. It has been deployed. And now if we do a request for Sys API, we get the response hello world version 1 exactly like we would expect. So this has worked. Now, what can we do if we want to do API versioning? As we've seen, this is version 1. Let's say we also want to have version 2. Let's go back into our stack over here, get into the editor so we can make changes. And let me copy that one as well and paste it in here again. I'll try again. Here we are. So now we could have a production endpoint, and that one, as you can see here, now has -prod, and it has the sys API /v1. Again, now it's stripping a different prefix, so we have to modify our middleware again. Now it's removing the sys API v1. If I deploy that one exactly and go back into the back here, remove that one, that was the unversioned one. Now we only have our prod image. If we do the same request, nothing is listening because we now have to add v1 as we've defined now v1 as prefix, and it's now in the middleware stripping v1 as well. Now that we have v1, we can of course easily add v2. I guess you can already imagine how that will work. Let's go back into our editor and just add another service, for example, for dev. That one now has version 2, as you can see here. Again, port 80 HTTP, and it's now connected to /v2, and it also has a strip prefix middleware that is connected to v2. So if we now go back into our client and use copy that one, put it into a new request, say v2, and send that request, oh sorry, v1 first as verification that it still works, and now send it to v2, and you can see now we have a response of v2 as well. So the different routing has worked, the different middleware has stripped the different parts, and that one works. Now, if we also add something like /URL, then we can see here the URL that is coming in. So you can see the container is getting a request using HTTP because Traefik is making the switch from HTTPS to HTTP, and it has URL in the end. And if you take a look at the headers, you can also see that we have those X forwarded for, forwarded proto, forwarded prefix, and those show us what the original request was. For example, the prefix here originally was sys API v2, and that one has been removed by our middleware. So this is interesting if you want to still react to the original URL, you still have that information. So in your application, you could take a look at the headers like I'm doing here, and then, for example, do different responses. The reverse proxy is not removing them, it's just setting them to those forwarded headers, which of course is also configurable. Now what I want to do is I want to show you something else if we want to do a different routing rule. So now we still have the path prefix sys API v1, but we could also do a different one as an OR connected rule, which has a prefix of sys API and a query of version equals v1. So if you want to add the version information not through the URL, but instead through the query. Now we need to strip both sys API v1 and sys API because it can have both ways to connect to it. And if we deploy that one, it should be in effect immediately. So we go back in here. The v1 request should hopefully still work. Let's see. Yeah, we still are here. So the same based on the path still works. But now we can also do the same by using a query parameter. So if we say version equals v1 and send the request, that also now works and gives us the same result. So basically, using Traefik as a reverse proxy, you can, as we've seen here, API versioning in different ways, through the path, through the query. If we take a look at the URL again, then you can see that it also adds the version equals v1 to it. And if we take a look at the headers, you can also see that now the forwarded prefix is only sys API because it's only stripping that part. So the middleware is only adding that information to the forwarded prefix headers. Okay, so let's make one last change, one other middleware that I want to show you, and that is the one for authentication. So what I'm adding here is a basic authentication. I'm adding a basic user configuration, which has a username of user and that particular password, HE password encrypted. And then we have an additional middleware that we need to register. So we now also have our authentication middleware, which this particular connection needs to listen to. So if we deploy that one and get back into our client, let's see, deployment has worked. Go back into the client and now do the same request as before. We didn't change the backend, but because of the middleware, it now says unauthorized. We know that it's listening to basic authentication. So if we add an authorization header, basic user, and then the password that I've defined, you can see very complicated one, then the request now works. So this is also interesting to give you an idea that you not only can remove things, add things, but also kind of add functionality like the authorization just by adding that information over here. And if we do the same here, you can see that the other way to route to the same service also works. So if we remove that one and do a /v1 instead and send the request again, it also has the same reaction. It also still works. So we only define the middleware once, and then it works depending on the different paths. Okay. So that was how we can do versioning, how we can do authentication. Just to give you an idea, this is the full list of available middlewares. Again, you can extend that if you need something else, and I don't want to go through all of those in detail. Just to give you an idea how much is there and what the kind of thing is that you can typically do with a middleware. But if it's not enough, if you need something else, then you can extend it with your own code and with your own solution. So again, this would be the moment where I ask for questions. Let me take a look at the Q&A. There is nothing in here. So I know there is a bit of a delay between the stream and the and where I am now. So I'll give this a couple more seconds to see if something comes in, but actually we're 2 minutes past the time. So with that, I want to say thank you again. Thanks for your time. Thanks for listening. If you want to get in touch, talk about the topics that I shared today, feel free to do so. I've shared my contact information on the first slide, so you can just go back there. And of course, if you're watching additional sessions at Global Azure, have fun with those and keep learning with all the amazing content that you see during that conference. Again, thanks a lot for your time.